spectral resolution. Spatial resolution, radiometric resolution, and temporal resolution. We'll first start with spatial resolution. Okay, so this depend on the requirement of data. Okay, okay, what kind of sensor resolution we have to use. Okay, because each resolution have specialities. Sorry. Okay, for example, for spatial resolution. Okay, in case of spatial resolution, you can easily identify the smallest size of the object in the image. Okay. Smallest size, the smallest possible feature can be detected. Size of the smallest possible feature can be detected with the help of spatial resolution. Okay, means we can study the every detail in the image. Okay, or photo imagery. Okay, because you can compare between the sizes of the smallest possible object as well. Okay, so you can come to know, you can have idea about the relative size. Okay, then you can match with this photo imagery scale like this. So such type of detail is also possible with the help of, if you are taking your photograph or aerial photograph with the help of spatial resolution. Okay, means let's say if your sensor is having spatial resolution of 20 meter, if sensor having spatial resolution of 20 meter, is having spatial resolution of 20 meter, and image is having, sorry, image is displayed at full resolution, then your image will have 20 meter by 20 meter size each pixel. Okay. Let's say if your sensor is having 20-meter spatial resolution, okay, and your image is displayed at full resolution, means in the photograph, okay, in the photograph, let's say this is your photograph, okay, which is divided into number of pixels, you know that, okay. So each pixel, then the size of each pixel will be 20 meter by 20 meter. So each square is representing 400 meter square area. Okay, this is the 20 by means 20 meter length, 20 meter height. So both are same means this should be square. Okay, so area of each square is 20 multiplied by 20 means 400 meter square. Okay, that means if your sensor resolution of 20 meter. Have you seen the movie Parmanu? जॉन अब्राहम की अच्छी मूवी देखते ही नहीं. Okay. So in that movie, you might have seen that watch scene. Okay. So in NASA, मतलब मूवी में ऐसा दिखाया गया है कि नासा के लोग सैटेलाइट से जॉन अब्राहम के घड़ी का टाइम देख लेते हैं, हाथ की घड़ी का, और उससे पता लगता है कि वो वेपन को कब फायर करने वाले, कब टेस्ट करने वाले थे. So that movie was based on first nuclear test. Okay, carried under the Atal Bihari government. Okay, so we had lots of sanction just because of that test. Okay, but that test improve our defense strategies. Okay, now we have nuclear weapons. Okay, almost 115 nuclear weapons. Okay, 5 to 6 less than Pakistan. So we need to test the nuclear weapon, and that was the first test. Okay, Parmanu. So means resolution, there is spatial. What is resolution actually? Okay, let's say I am saying resolution of 20 meter means we can means with the help of satellite. Okay, I can observe that every detail up to 20 meter. Okay, मतलब सैटेलाइट से मैं 20 मीटर तक की दूरी, ग्राउंड से 20 मीटर दूरी तक की हर चीज को अच्छे से देख पाऊंगा. Okay, means let's say you are standing on a 20-meter tall building. Let's say on the ground you are standing on a 20-meter tall building. Okay, so I can watch you clearly with the help of satellite. समझ में आया मैं क्या बोल रहा हूँ? Let's say if I am having a spatial resolution of 20 meter, okay, and you are standing on a 20-meter tall building. Okay, so with the help of satellite, okay, with the help of satellite, I can clearly watch you, monitor you with the help of satellite, because my spatial resolution is 20 meter. Okay, but up to 20 meter, ये भी ज़्यादा हो गया. Okay, nowadays, or some people say that USA have spatial resolution up to 5 to 6 meter. 5 to 6 मीटर मतलब जमीन पे 5 से 6 मीटर ऊपर जितना भी जो भी चल रहा होगा, या 5 से 6 मीटर ऊपर से वो सब कुछ देख सकते हैं विद द हेल्प ऑफ सैटेलाइट, किसी भी देश का. ओके, मीन्स विद द हेल्प ऑफ सैटेलाइट आई कैन watch every detail on the ground from about 20 meter if I am having a resolution of 20 meter. So now USA have 5 to 6 meter of resolution, and according to some rumors, ISRO have spatial resolution of 1 or 2 meter. Okay, हमने उससे भी एडवांस बनाया है. Some people say it is a Navik, advanced version of Navik, only used for defense and military purposes. बट दैट इज द रीजन, वो सीक्रेट है। ओके, तो रूमर है, बनाया है नहीं बनाया है, बट हो भी सकता है, इट इज पॉसिबल। ओके, सो इन दैट मूवी ऐसा दिखाया गया है कि घड़ी का टाइम भी देख सकते हैं सैटेलाइट से। उस समय वो थोड़ा ज़्यादा था, बट नाउ इट इज पॉसिबल। दिस इज द इफेक्ट ऑफ रिजोल्यूशन। क्लियर हुआ स्पेशल रिजोल्यूशन? So again, the based on spatial resolution, we have two types of sensors. Okay, we have two types of sensors. One is okay, low resolution, also called as coarse resolution. Low resolution or coarse resolution. Then high resolution, you can say fine resolution. सब लोग सच में उड़ गए हैं ना? थोड़ा सा हाँ नहीं, कुछ चैटिंग में, यस नो, थोड़ा ट्राई टू इंटरेक्ट.
कुठले सर?
हां, तर बरं असं वाटतं मी एकटाच तर नाही बरोबर. Okay, so that 20 meter by 20 resolution means that area or pixel area is equivalent on ground actually. Okay, so if you are having 20-meter resolution means your pixel will be of a size of 20 meter by 20 meter on ground. 400 स्क्वायर मीटर का फोटोग्राफ नहीं होगा. Clear? So based on means we have two type of spatial resolution. One is low resolution. Low resolution is also called as coarse resolution, and high resolution is not means very fine resolution. Okay, if you are using low spatial resolution means only you can observe large features. Okay, you can say large features are clearly visible. Large features are clearly visible. Let's say you can watch mountains, rivers, okay, with the help of low resolution. And with the help of high resolution, you can say small objects can be detected. Small objects can be detected. Okay. For example, military sensors. Here. So this is about spatial resolution.
सर लो रिजोल्यूशन हाई रिजोल्यूशन का ऐसा कोई रेंजेस नहीं है क्या, कहाँ तक रिजॉल्व कर सकते हैं जो दोनों को डिस्टिंग्विश करता है?
See, if your resolution, with the help of resolution, if your small objects are, if you can identify the small objects, okay, you can watch small objects from the photograph, then it is high resolution. Okay. If you are not able to distinguish between the small objects, then it is low resolution. Okay, it will vary. See, with the help of this satellite, okay, we cannot watch anything live. Okay, हम live नहीं देख सकते. Okay, if you want to spy on anybody with the help of these satellites, okay, you need to take the photograph. Okay, and with the help of photograph you can identify कि वो क्या कर रहा है, like this. Okay, तो ऐसा बोलते हैं जब ओसामा बिन लादेन को उड़ाया था, ओके, तो उसकी लोकेशन भी सैटेलाइट डाटा से कंफर्म की गई थी. उनको लोकेशन मिल गई थी, फिर उन्होंने इससे देखा था, से सैटेलाइट से, तो बिल्डिंग के ऊपर दिख गया था. तो उन्होंने कंफर्म कर दिया, तो सीधा बॉम्ब डाल के बिल्डिंग को ही उड़ा दिया पूरा का पूरा पाकिस्तान में घुस के. सो लाइक वाइज, okay, so this uh, satellite data is very useful in military purposes because we can identify small objects. Okay, so we can find out the militants, weapons, okay, any uh, illegal activity, underground tunnels, and etc. Like this. So it is not available for common people. Yeah, but low resolution is available. Okay, you can see in your Google Earth. Google Earth चला है किसी ने? Okay, download Google Earth in your mobile or laptops. Okay, you can understand. Yeah. Then next, second is your spectral resolution. Spectral resolution. Okay. What is spectrum? First tell me, what is spectrum?
So range of wavelengths or
Range of wavelength
bandwidth.
or band of, okay, particular channel, band of wavelength, you can say. Okay, that is spectrum. Okay, so what is band? You can say band is nothing but a narrow range of wavelength where data can be stored. Okay, that is band or channel. Now in case of spectral resolution, see, majority of the aerial photographs are black and white. Okay, that black and white photographs are called as panchromatic images. Okay, you can say majority of the aerial photographs. Okay, you have seen many black and white aerial photographs. Let's say they are panchromatic images. Okay, so if they are black and white, means you are using a spectral resolution, okay, in visible region. What is the range of visible region? Let's say 0.4 micrometer to 0.7 micrometer. Okay, so I'm using this particular one band here. Okay, I'm drawing one band, 0.4 to 0.7 micrometer. Okay, so you know that between this band you have three colors. Okay, blue plus green plus red. Clear? So now this band is consist of wavelength of three different colors. Clear? Okay, so if I am using spectral resolution or high spectral resolution, what I will do, I will separate these colors. Now in this case, first case, all these colors are combined. Okay, it is a common band of blue, green and red, and I am taking a photograph. Okay, but in case of high spectral resolution, what I will do, I will separate each band. Okay, I will separating green band, then red band, like this. So if I'm having 0.4 here, okay, then 0.5 here, 0.6 here, and 0.7 here. Okay, now green red band is separated. Okay, now with the help of high spectral resolution, now if I am taking any photograph, then I will get a colored photograph. Okay, so with the help of high spectral resolution, I can obtain a colored photograph. Now I am using three spectral bands. Okay, in my imagery, I am using three spectral bands. And in the first case, we are using one spectral band. Okay, so if you are using more than one spectral band, okay, to identify the greater details in your photograph, okay, you can say you are using multispectral. Okay, and if you are using hundreds of such narrow bands, okay, hundreds or more than hundreds of such narrow bands, then you can say you are using hyperspectral imagery. समझ में आया क्या आ रहा है? हम पहले एक बैंड को यूज कर रहे हैं जो बैंड तीन कलर का कॉम्बिनेशन है, दैट इज विजिबल रीजन. ओके, उसमें जब आप फोटो कैप्चर करोगे यू विल गेट ओनली ब्लैक एंड व्हाइट इमेज. ओके, सो विद द हेल्प ऑफ फर्स्ट केस, okay, 0.004 to 07, you will get black and white images, or you can say panchromatic images. Okay, but in case of higher spectral resolution, what I am doing, I am separating the bands. Okay, with the help of this separation, you can identify the smaller details in your imagery and in colors actually. Okay, so this is called as multispectral imagery. Okay, if I am using more than hundreds of such bands, okay, then you can say hyperspectral imagery, like this. Clear? So based on this, we have multispectral sensors and hyperspectral sensors. Multispectral sensors and hyperspectral sensors. Okay, so here remote sensing system, RS for remote sensing, record energy over several separate wavelengths. Ranges at various spectral resolution. And in case of hyperspectral, say it can detect through hundreds of very narrow spectral bands. Okay. Write one more line in spectral resolution. It describes ability of a sensor to define length intervals. Now see here. Understood? Spectral resolution. Okay. We can apply narrow bands. Okay. So that we can observe every detail in the photograph. Okay. So nowadays we are using hyperspectral sensor or hyperspectral technology for location of the for better location of the target. Let's say if you are developing, okay, let's say DRDO is developing any missile technology, okay, supersonic missiles, okay, means which can move more than the speed of sound, okay, they are supersonic. So they are developing a technology of supersonic missiles, okay. Now they need to locate the target, sorry, locate the target first, okay, which is far away from the point of source. Okay, so what we'll do with the help of this hyperspectral sensor, will identify the target. Okay, then with the help of coordinate system, we are going to locate the target, then we'll fire the supersonic missile. Okay, like this. Okay, so greater detail of the target can be studied, because if you are interpreting wrong target, then what will happen? Okay, तो गड़बड़ हो जाएगा. So this is the use of hyperspectral sensors. Okay, I am saying only military use. Okay, but we have so many other uses also. Okay, clear? Okay, we can also take uh, hyperspectral imagery in case of disasters. Okay, flooding, to study the damaged area. Okay, or you can say we can study if you know the every details of the ground, you can come to know, or you can get idea about the slope condition. Okay, if you know the slope condition, you can predict the direction of flood, okay, or the movement of water, excess water, okay, now which is flooding any particular river, like this. Okay, so we have multiple uses. Okay, with the help of spectral resolution, we can identify the differences between every object. Okay, because we can get colorful images with the help of hyperspectral data. Clear? So this is about spectral resolution. Clear? Then third one. Clear? Any doubt up to this? आगे बढ़ो. Okay. Third one is radiometric resolution. Radiometric resolution. So this radiometric characteristics describe actual information image. Radiometric characteristics describe the actual information content in an image. Okay, so again we'll understand this with the help of one example. Okay, so every time we represent imagery data, okay, with the help of digital numbers. Represent with the help of digital numbers, okay, which may vary okay, which may vary from 0 power of 2. Power of 2 and power of 2 kitna rahega, it will depends on the how many bits you are using in your image. Okay, every time we represent imagery data with the help of digital numbers. Okay, okay, because all the machines are doing the actual work. Okay, so we know when we have to give them a digital numbers. Okay, so it will your digital number starts from 0 to power of 2. Okay, power 2 to the power 4, let's say 2 to the power 8, likewise, etc. Okay, minus में नहीं रहे. Clear? Now let's say, and your maximum brightness value depends on how number of bits or how many number of bits you are using. Okay, so I can write maximum brightness value is directly proportional to bits. Let's say your sensor is having 8 bits of resolution. Okay, 8 bits of resolution. Okay, now here I am comparing 8 bits radiometric resolution and 4 bits radiometric resolution. Here, so 8 bits. So you will have now calculate the digital numbers for 8 bits. Okay, first we'll calculate the digital number for 8 bits. You know, your digital number start from 0. Okay, and up to the power of 2. Okay, so now we are using 8 bits, means we are using 2 to the power 8. Okay, so 2 to the power 8 कितना हो जाएगा? ज्यादा होगी. कितना होगा? आधा थोड़ा 256. Okay, so now if you are using 8 bits imagery, means you have total 256 to the power 8 digital numbers. Okay, means which one? From 0 to your maximum digital number will be 255. Okay, 0 को भी count करेंगे. If you are counting 0, okay, So if your imagery is 8 bits, means you will have maximum 256 brightness values. Okay, and 256 brightness value, or you can say 256 digital numbers. Okay, from 0 to 255. So your last digital number will be 255, not 256. Clear? Because here we are counting 0. Okay, clear? So if in any imagery, if you are having 256 brightness value, okay, then you can study, okay, that particular image in very detail. Okay, because we have 256 variants and 256 brightness value. So every possible detail we can identify from the particular 8-bit imagery. Clear? If you are using 4 bits, means you will have 2 to the power 4 digital numbers. Kitna ho gaya? You will have only 16 digital. Okay, no, only 16 digital numbers, means from 0 to your last digital number will be 15. Clear? So you are having 0 to 15 digital numbers. Okay, so now in your 4-bit imagery, you are having a particular, 4 bits data. Okay, means you are having only 16 brightness values. Okay, so if you compare the 8-bit image with the 4-bit image, okay, so 8-bit image is more beautiful. Okay, and it will give you more information if you compare with the 4 bits imagery. Clear?
सर ये लास्ट पॉइंट 0 to
जरा पुन्हा सांगा ना एकदा.
See, what is radiometric resolution? Okay, means it is a resolution of your sensor or camera, you can say. Okay, so again, with the help of this radiometric resolution, we can identify every detail of the ground surface with the help of imagery. Okay, so we need to regulate them. Okay, so we have 2 bits imagery, 4 bits imagery, 8 bits imagery. Okay, now these bits, okay, any digital imagery is represented with the help of pixels. Okay, अभी तक जो देखा हमने पिक्सल से देखा. Okay, now we are
Yes, sir.
with the help of radiometric resolution, we are representing them with the help of bits. Okay, so let's say if you are having 8-bit imagery, okay, or 8 bits of radiometric resolution in your sensor, means you have maximum 2 to the power 8 256 brightness values. Okay, 256 brightness value, in which your maximum brightness value is 255, because here we are counting 0, we are starting from 0, not from 1. Okay, if I am saying 256, means I will start from 1, but I am saying this, but here I am counting 0, okay, as a 1. That is the reason we are having 255 is your last or maximum brightness value. So if you are using 4 bits imagery, you will have maximum 16 brightness value, so 0 to 15. So number 15 will be your highest brightness value. Okay, like this you can also have 2-bit imagery. If you are having 2-bit imagery, means you are having maximum 2 to the power 2, means 4 bits, 4 digital numbers or 4 brightness value. Clear? For 2 bits. So if you compare this imagery, so obviously if you are increasing the bits, okay, you will improve your imagery. Okay, clear? The higher the value of bits, so greater detail you can study from your imagery.
Okay, sir.
Clear? So this is about radiometric resolution.
सर ते मी ऐकलं होतं की मार्स रोवरचे काहीतरी बिलियन्स मध्ये पिक्सेल्स होते म्हणून.
असेल.
मग आपण सेम त्याला डिवाइड करू का असेच या पॅटर्न मध्ये 8 बिट किंवा 4 बिट मध्ये? 8 बिट मध्ये
नाही, त्याच्यात अजून हायर राहील. इथे नॉर्मल फोटोग्राफचं एक्झाम्पल आहे.
ओके सर.
Okay, if you are observing or you are using satellite for any space searches, और वो बहुत distance पे होते हैं ना, so you need higher वेरी हाई रिजोल्यूशंस. ओके, एक्चुअली स्पेस के लिए कितना यूज करते हैं मुझे भी आइडिया नहीं, बट डेफिनेटली दे विल यूज हायर रेजोल्यूशन सो दैट, क्योंकि वैसे भी बहुत बहुत दूर पे है ना.
बहुत दूर है.
क्लियर?
ओके, ठीक है सर.
This
ओके.
is about radiometric resolution. Now, last is temporal resolution. Temporal resolution. Okay, you can remember this temporal resolution with the help of time. Time bracket में लिखो so that you can easily remember temporal resolution. What is temporal resolution actually? Okay, this resolution is based on time. Means, let's say अगर किसी को हाउस अरेस्ट कर लिया, or you can say, let's say I need to spy on Mayank. Okay, this is Mayank. Okay, now with the help of satellite and temporal resolution, what I am doing, okay, I'll capture the imagery of Mayank, let's say on 1st January. Let's say on 1st January. Okay, okay. So I have captured the photograph of Mayank on 1st January. Okay. Then let's say in 2015. Then what I will do again next year on 1st January in 2016, मैं फिर से मयंक का फोटोग्राफ कैप्चर करूंगा अगेन ऑन 1st Jan. Okay, 2016. Then I will again capture the photograph of Mayank on 1st January 2017, like this. Now I can compare the three imageries of Mayanks. Okay, from 2015, from 2016, from 2017. Okay, now I can see the growth. I can get information about the growth of Mayank. Okay, वजन तो नहीं बता पाएंगे. Yes, but you can little bit say about the height. Okay, appearance, like this. Means in this temporal resolution, or with the help of temporal resolution, you can capture the image of same object at different time intervals.
Relative studying.
Yes, relative study. Means this is very helpful in case of vegetation. Okay, what government is doing actually, this is very helpful for government. Okay, this is very helpful for government. Now you know in India farmers are protesting against the farm laws. Okay, very hot topics. Now you know the concept of MSP. इससे पहले बहुत लोगों को MSP क्या होती पता भी नहीं होती. Okay, now it is hot topic. So what is MSP? What is MSP? Okay, you can say it is a maximum price of a crop. Okay, so what government is actually doing? Okay, government is buying the crop. Okay, crop or crop produce from the farmers directly. Okay, so government of India is buying, let's say 70% production from Punjab. Okay, 80% production from Haryana. Okay, because दे आर सो रिच इन एग्रीकल्चर. ओके, तो गवर्नमेंट क्या करता है, गवर्नमेंट इज बाइंग बेस्ट क्वालिटी ऑफ प्रोडक्ट्स, ओके, at MSP, maximum price of the crop, okay, at MSP from the Punjab and Haryana, okay. और अपना स्टॉक जो फूड डिपार्टमेंट है इंडिया का उसको स्टॉक कर लेता है, ओके. नाउ गवर्नमेंट विल सर्क्युलेट दिस प्रोड्यूस, ओके, जो सस्तं राशन धान्याची दुकान यू कैन से, ओके. Okay, now government can freely distribute that produce in entire India. Okay, सस्ते दाम में. Okay, government is buying, let's say, wheat at a price of 22 rupees per kg from Punjab and Haryana and other states. Okay, but government is actually maximum buying from Punjab, Haryana. Okay, then they are distributing this produce to entire India. Okay, with subsidized rate. Okay, so now in this case, if you are the authority, you need to decide, okay, कि कितना बाय करना चाहिए और कितना पैसा आप उस पर खर्च कर सकते हो और कितना आपको लगेगा बांटने के लिए. ओके, सो लेट्स से क्या होगा, लाइक इन अ लॉकडाउन, ओके, गवर्नमेंट नीड मोर क्रॉप प्रोड्यूस टू डिस्ट्रीब्यूट विद इन दी पुअर पीपल्स. ओके, so how will you come to know about the production of the entire India? ओके, या प्राइम मिनिस्टर ऑफिस को कैसे पता चलेगा, कोई किसान जाके थोड़ी बताएगा कि दे आर प्रोड्यूसिंग 20 बोरे को 20 silos, ओके, 20 silos ऑफ वेट, सर आई एम प्रोड्यूसिंग 100 silos ऑफ वेट, ऐसा तो कोई बताएगा नहीं. ओके, so what government is doing, okay, government is ordering a particular remote sensing department, okay, and they are using temporal resolution. Okay, now let's say if some crop is of 3 months, let's say I'm considering wheat. Okay, let's consider the wheat crop. Okay, let's say 6 month crop. Okay, कितना है मुझे भी नहीं मालूम, मैं फार्मर नहीं हूँ. Okay, let's say 6 month crop. Okay, so if I am planting wheat in the month of January, let's say, okay, so from the month of January up to June, okay, I am monitoring the crop fields of entire India. Okay, I am monitoring the wheat fields of entire India. Okay, so I will take the aerial photograph of the wheat fields in the month of January. Okay, then I will take the photographs of wheat fields in the month of February, March, April, May, June. Okay, with the relative study of all 6 imageries, I can say or I can gather information about the production of wheat. ठीक है, कि इस साल बहुत ज्यादा wheat का production हुआ है. Okay, so according to that, government, okay, I will decide the MSP. बहुत ज्यादा प्रोडक्शन हो गया तो क्या करेंगे, हम MSP को कम कर देंगे. तो कम करेंगे सो ज्यादा से ज्यादा प्रोडक्शन को हम बाय कर सके कम दाम में. Okay, if as per the demand, if your production is very less, let's say some fields are damaged due to let's say hailstorms and excessive raining. Okay, production ही कम हो गया. Okay, you can clearly identify with the help of temporal resolution. So what I will do, I will increase the increase the MSP. Okay, रेट ज्यादा पड़ेंगे और मैं कम बाय करूंगा. Okay, so automatically in market the prices of wheat will increase due to less production because demand is higher and production is less. So automatically rate will go up. Okay, like this. So ये सारी चीजें, okay, I can plan all this thing with the help of satellite imageries. Okay, so government remote sensing department is continuously monitoring, okay, every crop. They are monitoring every crop, okay, so that they can gather the information of the every crop. Then they will decide the MSPs. Okay, और उसके हिसाब से बजट प्लान कर रहे हैं कि कितना बाय करना चाहिए, कितना नहीं करना चाहिए, कहाँ से करना चाहिए. ओके, Clear? Like this. समझ में है? Clear? So okay. That is the reason government people know everything about the country. Okay, because they have all the resources. Okay, nowadays remote sensing is very helpful in every planning. Okay, if they are planning for highways, let's say, okay, remote sensing is useful. If they are planning for any bigger project like dams, tunnels, etc., okay, for flood monitoring, landslide monitoring, defense purposes, okay, so now everything is based on remote sensing data. Military operations, you can say, protest management also. Okay, कितने एरिया में लोग बैठे हैं वो भी सैटेलाइट डाटा से पता कर लेंगे फटाफट, कहाँ बैठे हैं, कहाँ ज़्यादा हो रहे हैं, कहाँ कम हो रहे हैं. Okay, with respect to that, they can plan their strategy to restrict any protest like this. So this is the help of temporal resolution. So USA at the time of first nuclear test of India, they are using this temporal resolution. Okay, और वो कंटिन्यूसली 2 सालों से अपना एक सैटेलाइट इंडिया के ऊपर फोकस करके हमारी पोखरन, दे आर वॉचिंग पोखरन वेरी क्लोजली. Every day they are taking the images of Pokhran fields. Okay, and they are studying the every inch movement of any vehicle in the Pokhran area because they have idea about the nuclear testing कि इंडिया ऐसा कर सकता है. Okay, and they are doing every possible way to stop the particular nuclear test of India. Okay, तो कौन था, शायद जॉर्ज डब्ल्यू बुश था, मालूम नहीं कौन था, बट दे आर रोकने के लिए हर संभव कोशिश कर रहे थे. ओके, बट इंडिया ने भी उनको घुमा के, प्राइम मिनिस्टर ने देख लिया, अटल बिहारी थे, जो होगा वो देख लेंगे बाद में. सबको पता था इफ़ यू आर गोइंग अगेंस्ट यूएसए तो वो बहुत सारे ट्रेड सैंक्शंस लगाते हैं जिससे कंट्री को बहुत नुकसान भी हो सकता है. ओके, बट न्यूक्लियर वेपन टेस्टिंग इज वेरी मच इम्पॉर्टेंट. ओके, टू शो द पावर ऑफ इंडिया. ओके, जो कांग्रेस बहुत सालों से नहीं कर रही थी. ओके, एक बार हम कर रहे थे तो हम पकड़े गए थे जस्ट बिकॉज ऑफ दिस टेम्पोरल रिजोल्यूशन इन द कांग्रेस गवर्नमेंट. तो उसके वजह से वो रुक गया और उन्होंने और सख्ती कर दी, और उस ऑपरेशन से वो हर साल हर दिन हमें मॉनिटर कर रहे थे. एक सैटेलाइट सिर्फ हमें मॉनिटर करने के लिए लगा के रखे थे. ओके, दे आर वॉचिंग द पोखरन फील्ड कंटिन्यूअसली. ओके, विद द हेल्प ऑफ देयर वन सैटेलाइट. ओके, उन्होंने उसके ऑर्बिट्स एडजस्ट कर ली थी सो दैट दे कैन वॉच द पोखरन फील्ड. ओके, बट व्हेन एज द जैसे ही गवर्नमेंट चेंज हुई, अटल बिहारी वाजपेयी, उन्होंने पहला टारगेट वही रखा कि जो भी हो जाए, कुछ भी कर ले यूएसए, हम देख लेंगे. ओके, एंड अटल बिहारी ने परमिशन दे दी और इन्होंने सटासट प्लान कर दिया. ओके, व्हाट दे डिड, ओके, उन्होंने पीसेस में तैयार किया जो भी लॉन्चिंग टेस्टिंग मटेरियल्स. ओके, उन्होंने पीसेस में तैयार किया इन एंटायर इंडिया, इन एंटायर डीआरडीओ लैब्स. ओके, देन उन्होंने उसको माइग्रेट किया, तो फिर उसको असेंबल किया और बहुत होशियारी से उसको टेस्ट किया, और टेस्ट करने के बाद खुद ही जाहिर कर दिया कि हमने कर दिया, डंके की चोट पे प्रेस कॉन्फ्रेंस करके. ओके, फिर क्या हुआ, सब कुछ तो हो चुका था, थोड़े से सैंक्शन आए, कुछ महीनों तक चले, देन अगेन इंडिया के डिप्लोमेट्स ने डिप्लोमेटिक रिलेशंस बना के ट्रेड्स कम ज़्यादा करके थोड़ा सा चीज़ें खरीद के यूएसए से वो मैनेज कर ली, बाद में हट गए सैंक्शंस. सो लाइक दिस. ओके, तो एक बार वो परमाणु मूवी देखो आप. ओके, यू विल कम टू नो अबाउट दी हाउ सैटेलाइट इमेजरीज इज वेरी यूजफुल इन डिफेंस एक्टिविटीज. So this is about the resolutions. Okay, clear? Any doubt about resolutions? Clear? Okay. Now we'll move towards some other features, other things in remote sensing. Okay, so next topic is distortion and displacement. Okay, let's say distortion and displacement. In your photography, let's say if any one pixel is displaced from its original position. Okay, if your pixels are displaced from in original position. Okay, वही मैं आपको बता रहा हूँ. Let's say, okay, so if my nose is displaced in my photograph, okay, so you need to correct such things. Okay, that is the distortion. Okay, and what distance they are distorted, this is nothing but displacement. Displacement is shortest distance between two points. Okay, means you can say, okay, one person, okay, started cycling from point A, okay, and he followed this path up to point B. This is point B. Okay, he's exercising, let's say. Okay, now another person using and cycling like this. Okay, again third person आया, straight path follow किया. Okay, so out of these three path, जो shortest distance होगा, the shortest distance will be your displacement. Okay, so indicated with the purple path. Okay, the shift in position of a landscape feature on a photograph that alters the perspective characteristics of the image is called as distortion. Clear? And displacement, any shift in position of landscape feature, means if you are calculating the distance, that is nothing but your displacement. Shortest distance is displacement, and distortion means shift in a position, and it is happened just because of the errors, okay, in your instruments, in your sensor, in your resolution cameras, etc. Okay, you will get distorted image. Okay, I will show you one distorted image. See this. Okay, all these are distorted images. Okay, in this imagery you will see your pixels are displaced from the original position. Okay, now observe this photograph carefully. Okay, you can have little idea about the pixels. Okay, you can see all these are pixels. Okay, not exactly like this because all pixels are distorted here. Yes, here you have perfect pixel. Here you can study pixel from your this imagery. Clear? So this is your distorted images. Clear? Now, okay, draw this diagram, okay, and try to understand, try to remember the formulas. Okay. I will study the topographic displacement. Okay, just first observe this diagram. Okay, यहाँ पे कहीं पे तो भी आपका I है, let's say. Okay, and you are observing the feature with the help of lens. Okay, so this is your focal length. I will show you proper photograph. Just one second.
झाले का मोरी वगैरे धुणं झाले का माझी त्या एक का सगळं पाडत पडतो ना. मोरी वगैरे धुवून मला करून द्यायचं आहे. मी का कुठे बडबड करते.
Just one second. Draw this diagram. और कई फोटो ले लो या फिर ओके मैं शेयर तो करूंगा बट फॉर न्यूमेरिकल यू नीड टू अंडरस्टैंड डायग्राम एक्चुअली तभी आप उसको कैलकुलेट करना. फोटो ले लो नहीं तो कहीं भी पॉसिबल. ओके एंड राइट ओनली फॉर्मूलास. जस्ट ऑब्जर्व द डायग्राम. ओके चलिए तो देख लेंगे. h height of the landscape feature. Okay, small h. So this is your ground surface. Okay, this dotted line is showing your ground surface. This is your tree. Okay, this is your focal length. Okay, f. A altitude of area aircraft. Okay, so this much here you are having aircraft. Elevation of the landscape feature E. Okay, this is your landscape feature. Let's say elevation of the landscape feature. Then h flying height above the base of landscape. Okay, this is flying height above the base of landscape. Then r distance from the nadir to landscape, capital R. Okay, this is nadir to landscape. This is your landscape, let's say this tree. Okay, and this is your point of nadir. This is your nadir, let's say. Okay, so this distance is capital R. Okay, then यही अच्छी है क्योंकि इसमें मैंने समरी बना के रखी है. Okay, so like this. Then R is distance on the photo from nadir to displaced landscape, and R dash is actual place of the photo where landscape should be located. Okay, R dash is your distance or actual position जहाँ होना चाहिए. Okay, but and small r is the distance जो displace होने के बाद. Okay, so distance between after the displacement. Okay, just write down this formula, three formula. Okay, leave the diagram. So hd. Okay, small h and d. Okay, so what is small h here? First, height of the landscape feature. Okay, and d. What is d here? Okay, relief displacement. Okay, relief means boundary displacement, distance between two different boundaries. Okay, relief displacement. Clear? Write down these three formulas only. Clear? Okay, 3 more. Done? Now try to solve this numerical. Okay, flying height above the base of the landscape feature at nadir h. Okay, इस न्यूमेरिकल में मैंने थोड़ा इजी बना दिया, आपको लेटर्स दे रखे. ओके, ये दिए नहीं रहेंगे. ओके, you need to identify the exact values. Flying height above the base of the landscape feature at nadir, capital H is equal to 10,000 feet. Okay, then height of the landscape feature relative to nadir, h is equal to 1,000 feet. This radial distance from the nadir to landscape feature location on the photo is 3 inches. Okay, and what is the displacement on the photo relative to nadir? Okay, we will use this formula. D is equal to RH by H. Okay, we have radius 3 inch. Okay, height of the aircraft, height of the base in feet, feet get cancelled, you will get final value, your value of D in inches, like this. Okay, now give me the same value in feet. How much? What you will do? Now calculate the same value in feet.
2.6
क्या किया?
multiply 12.
मल्टीप्लाई किया.
Yes, sir.
Anyone? Any other? See, you are converting inches into feet. Okay, मतलब क्या कर रहे हो? छोटे से बड़ा कर रहे हो. तो छोटे से बड़ा करते तो मल्टीप्लाई करते कि डिवाइड? Yes, 0.02 डिवाइड करना पड़ेगा. Okay, you need to divide this value with 12. Clear?
Yes, sir. सर क्वेश्चन दिखाइए ना इसका. Okay, sir.
Now try to solve it. Now suppose we have the measured displacement of a tree on a flat ground. D is given 2.1 mm. The distance from the top of the tree to the nadir of the photograph is 79.4 mm. Okay, means R is given. The flying height of the aircraft A above the MSL is 10,000 feet. Okay, so capital H is given. Elevation of the area E. Okay, from a topographic map is given. So E is equal to 2,000 feet. So what is the height above the tree? E है, capital H है, you have R, you have small d. Okay, means you need to use second problem. Okay, जिसमें E है, capital E वाला. Okay, anyone? You have 1 minute. Okay, use this formula. H is equal to A minus E d by R, because here you have elevation. Okay, elevation of the feature. Okay, so substitute this value in the given formula, you will get H. Now tell me the final answer in inches. Done? Yes, 2539. 2539.2. Okay, what you will do, you will multiply the value of H with 12. Okay, to obtain the value in inches. Okay, because 1 feet is equal to 12 inches. Clear? It's like this. Clear? Okay, so this is how you can solve the numerator with the help of formula. Okay, so with the help of this diagram, okay, just try to remember all 6 formulas. Okay, we don't have numerical on every formula. Okay, but can understand. Okay, I will share this material today. Okay, now we need to study some data now. Okay, this portion of 10 to 15 minutes is little bit boring, but we need to gather information about, study information about some names of the satellites, resolutions of the satellites, okay, launching dates of the satellites, okay, some of the important satellites of India and world. Okay, now we are just observing the data. Okay, तो हम थोड़ा उसमें रीड ही करेंगे, बाकी कुछ है नहीं. Okay, this is because data of the satellites. Okay, so first tell me what is radar. You know radar. Radars are using radio frequencies. Okay, you know the electromagnetic spectrum. Okay, in the electromagnetic spectrum, in the right hand side of the diagram, you have radio waves. Okay, which is having highest wavelength. Okay, if any wave, if you are having highest wavelength, okay, means it can travel to longer distances. Okay, that is this is the important thing about higher wavelength. Okay, and that is the reason we are using radars. Okay, for aircrafts. Okay, for flights navigation जो है वो सब radar से होता है. Okay, also we are using radars in ships, naval ships. Okay, clear, क्योंकि वहां तो टावर है नहीं कि बाकी सिग्नल काम करे. Okay, समुद्र के बीच या हवा में कहीं पे. That is the reason we are using radar. Okay, radar is called as radio detection and ranging. Okay, it collects backscattered energy, then multi-amplified and analyze the determined location of the properties. Okay, so what radar will do, let's say this is your target. Okay, at the bottom of the sea or somewhere in the airspace. Okay, or in the atmosphere, let's say. What radar will do, radar will transfer radio frequencies to this particular target. Okay, when radio frequencies strike with the object, okay, it will backscatter. Okay, it will backscatter, and radar will detect this backscattered frequencies. Okay, and With the help of backscattered frequency, it will amplify and analyze so that you can calculate the distance. Okay, let's say एक missile आ रही है fighter plane के तरफ. Okay, so immediately it will throw the radio frequencies toward the target. Okay, and immediately measure the backscatter, and will come to know about the distance of the any missile coming towards the aircraft, like this, so that we can navigate the aircraft. Okay, same techniques are used in ships also. Okay, to detect the location or the distance of the torpedoes. Okay, like this. They are very helpful radars. Then we have so many remote sensing satellites, starting from Bhaskara 1 and 2. Okay, built by ISRO, India's first low orbit Earth observation satellite. Okay, we are using Bhaskara for low observation, Earth observation. Okay, collects data on telemetry, oceanography, hydrology. Okay, then we have CSAT. Okay, managed by NASA, launched on 27 June 1978. First Earth orbiting satellite designed for remote sensing of Earth's ocean. Okay, CSAT. Yeah. Then we have Skylab. Okay, then we have Skylab, first space station of USA, orbiting Earth from 1973 to 1979. Okay, उसके बाद गिर गया था ये Skylab, used for solar observation, systems necessary for crew survival and scientific experiments. Okay, Skylab. Then SPOT, System for Observation Dilatary. मालूम नहीं कैसे पढ़ते हैं इसको. It is a series of Earth observation imaging satellite designed and launched by NES, Center National. ये भी नहीं मालूम, फ्रांस का है ये. कुछ तो भी उनका प्रोनाउंसिएशन होता है, वो डैश लगा के ऐसा कुछ तो भी है. So it is SPOT is managed and operated by France. Okay, first along track push broom scanning technology. Okay, used first time they are using push broom scanning in SPOT. Okay, used for commercial urban mapping. Okay, means they are city planning, design of the highways, roads, squares, like this. SPOT. Okay, then I told you about the atmospheric windows. Okay, so here the table of some important atmospheric windows. Okay, many times you will find your objective question based on this atmospheric window. Okay, so which one of the following is a correct atmospheric window for reflected infrared region? Okay, like thermal IR region, like this. Okay, you need to remember all these values. So upper UV for ultraviolet or visible and photographic IR infrared region. Okay, 0.3 to 1. Okay, then for reflected IR, we have 1.3, 1.6, 2.2, 3 narrow band. For thermal IR, 3 to 5 and 8 to 40, 2 broad bands. And for microwave, more than 5,000. Okay. Okay, then we have one numerical. Again, this is also important. I think 2018 gate में आया था. Okay, what is sun synchronous? Okay, read the question. A sun synchronous satellite is at an altitude of 300 km. Okay, now you know the height of the satellite, and the spectrometer makes an angular coverage angle of 12 degree. The SWAT, GFOV. Okay, we have studied the IFOV. Okay, instantaneous field of view. Okay, means what is GFOV? Let's first understand. Let's say this is your plane. Okay, So what is IFOV? It is the angular cone of visibility. Okay, let's say. Okay, this theta is your IFOV, angular cone of visibility. Okay, with the help of this, you can observe this much of area. Okay, you can say this is the coverage area. Okay, at particular instant, right? Coverage area at particular instant. Okay, now this aircraft is moving in atmosphere. If you are observing from satellite, let's say from geostationary satellite, okay, तो क्या हो जाएगा? GFOV बन जाएगा. Okay, so now consider geostationary satellite instead of this aircraft. Okay, then you can get GFOV. Clear? Geostationary field of view.
Sir, can you repeat?
Geostationary field of view. Okay, now consider air satellite. Okay, geostationary satellite. Let's say this is your geostationary orbit, and this is your Earth. Clear? Okay, instead of aircraft, just consider your geostationary satellite. Then this angle will be your GFOV. Okay, so it is given 12 degree. The swath. What is swath? Swath is the path. We need to calculate the swath. Okay, so we have one formula for GFOV, H multiplied by tan theta. Okay, the angle is given, height of the satellite is given 300 kilometer. Okay, so simply substitute the values, you can get, okay, can get this swath 63.75 kilometer. Clear? Then again one table, okay, to give you the information of spectral region. Which spectral region is important for what purpose, okay, and in what system they are used. Okay, let's say the blue spectral region. Okay, what is the wavelength for blue region?
0.4 to 0.5.
0.4 to 0.5, correct. Okay, micrometer. Similarly, 400 to 500 in nanometer. Okay, so blue region. Okay, principal use for water body penetration, forest type of mapping. Okay, you are use thematic mappers. Okay, thematic mapping होती है. Again, one type of remote sensing. Okay, now it is very widely used, thematic mapping. We are using this blue spectral region in case of thematic mapping for water body penetration. Green, green reflectance peak in vegetation. Okay, so if you are monitoring any forest areas, okay, or crop fields, okay, then you will use green color band. Okay, again used in multispectral scanning, MSS, thematic mapping, TM. Okay, ये कुछ नहीं है, काटा है वो गलती से. Okay, then if you are using red band, so chlorophyll absorption. Okay, discrimination of vegetation type. In that case, red band is useful. Okay, all these are the names of sensor: TM, MSS, XS, AVHRR. अच्छा ये है लगता है XS. Okay, ऐसे बहुत सारे हैं. Then near infrared, discrimination of vegetation type, density, biomass content, water absorption, soil moisture. Then for mid IR, vegetation moisture content, soil moisture, TM, thermal, vegetation stress analysis, soil moisture discrimination, all this. ओके, ये चीजें कोई पढ़ाएगा भी नहीं, कहीं अवेलेबल नहीं है, पर मैंने हर चीजों को डाटा कलेक्ट करके रखा है. सो दैट्स द रीजन आई एम शेयरिंग दिस ऑल डाटा. ओके, इट्स वेरी इंपॉर्टेंट from objective point of view. Okay, So I have collected the entire data. So एक जगह पढ़ने में आसान हो जाता है. That is the reason. Okay. Then we have Landsat. Okay, Indian satellite. Okay, in Landsat 3 we are using RBV sensor, band number 1, in the wavelength range of this much, and resolution 40 by 40 meter, like this. Okay, we have, this is Landsat 3. Okay, then Landsat 4, 5. Okay, in which we are using multispectral scanning and thematic mapping. Okay, we have so many band. Okay, and wavelength for each band, resolution. Okay, 82 meter, 30 meter, 30 meter, and so on, like this. Okay, थोड़ा सा बोरिंग है पर 5 मिनट थोड़ा पेशेंस रखो. Then data for spot 1 to 3. Okay, here pan chromatic. Okay, resolution for pan chromatic is 10 meter by 10 meter. Spot 5, altitude 822, inclination 98.7 degrees, orbit sun synchronous polar, period of revolution 101 minutes, swath width, repeat cycle, like this. Then high resolution geometric sensors. Okay, HRG. Okay. So in multispectral, we are using B1, B2, B3, and sphere band. Okay. The resolution is given like this. Okay. Then again we have HRS sensors. Okay. Again band, swath, resolution, IRS, Indian Remote Sensing Satellite. Okay, IRS system. This is important. Okay, so this is Indian system. Okay, and still nowadays means still we are using this system with some modifications. Okay, so linear imaging self scanning, LIS 1. Okay, nowadays we are using LIS 3 mostly. Okay, linear imaging self scanning third, LIS 3. Okay, so in LIS 1 we are using 72 meter resolution. In LIS 2 we are using 36 meter resolution.
Sir, what are sensor channels?
Huh?
Sensor channels.
Channels mean bands. Bands, LIS 1 band, LIS 2 band. Band number. Okay, band is the particular spectrum in which we can store the data. Okay, and is here we have the wavelength or spectral band. Clear? So एक बार LIS 3 का resolution पूछ रहा था. Okay. We have one question, objective question. What is the resolution of LIS 3? That is 23 meter. In option, only 23 is given. Okay. With some other options. That is the reason I have collected so much data. Okay. तो आपको इतना सारा collect करने की जरूरत नहीं. Simply try to read and remember like this. Okay. So we have what kind of sensors we are using in IRS. We are using LIS 1, LIS 2, LIS 3, then LIS 4, high resolution, linear imaging, self-scanning. Okay, then WIFS, wide field sensor. Okay, and AWIFS, advanced wide field sensor. Okay, this table is important. Okay, बाकी आप करो ना करो, इसको जरूर पढ़ना थोड़ा. Okay, this is mark this one important.
Sir, how do we receive those bands?
Bands को
Receive कैसे करते हैं?
मतलब कैसे कलेक्ट किया?
हाँ, कलेक्ट कैसे करते हैं?
अरे हम बनाते हैं उसको.
सैटेलाइट से अगर यहाँ आएगा तो कोई रिसीवर चाहिए ना उसके लिए.
हाँ तो हम बनाते ही वैसे है ना. हम बनाएंगे, टेस्ट करेंगे, देन ही सैटेलाइट को छोड़ेंगे. ये तो हम बना के भेजते हैं पर्टिकुलर बैंड में. ओके, we'll first we'll try to capture the imagery in this particular band. Okay, हमको अगर सच में as per requirement, if you are getting the imagery in this particular band, then we'll prepare such satellite, okay, or such scanner और उसको फिर फिट करेंगे सैटेलाइट में। क्लियर? ओके, छोटे से 2 टॉपिक कर लेते हैं। Now we have spectral reflectance. Okay, what is spectral reflectance? Okay, it's a fraction of incident radiation reflected by the surface. Let's say, okay, let's say this is your vegetation. Let's say this is your tree. Okay, so if you your scanners, okay, is actually measuring the backscattered radiation. Okay, so the spectral bands, okay, or the energy reflected from this tree, okay, they will receive the energy and measure the energy reflected from this tree, and based on that energy captured, okay, we will get some graph like this. Okay, valley peaks. Okay, these graphs are called as valley peaks. Okay, so you can see here is a fraction of incident radiation reflected by the surface of any object. Okay, if you observe this graph carefully, okay, we are comparing the spectral reflectance of dry soil. Okay, so in case of dry soil, you will receive the straight line like this. Okay, approximately straight. Then in case of vegetation, okay, we have valleys. Okay, like this. Number 1 at, let's say, 0.7. Okay, between 0.6 to 0.8. Okay, 0.7. Okay, this is your atmospheric window actually. What is atmospheric window? Region of least absorption. Okay, so if least absorption is there, means you will see the valley in your graph. Okay, then again here you will see at 1.4 you will see the valley. Okay, at 1.8 or 1.7 approximately you will see the valley like this. Okay, and for water you will see 0 to 0.8 like this. So these are the spectral reflectance curves. Okay, now we'll study at what particular place or locations we are getting such low atmospheric absorptions. Okay, so from the graph you will come to know about the abnormality on the ground. Okay, then you will go to the inspection. ओके, ग्राउंड पे जाओगे, पता करोगे ऐसा क्या हुआ कि यहाँ पे आपका स्पेक्ट्रल रिफ्लेक्टेंस कर्व जो है वो लो ऑब्जर्प्शन दिखा रहा है. देन यू कैन डिटेक्ट द एबनॉर्मेलिटी, यू कैन स्टडी द एबनॉर्मेलिटी. ओके, सो आपका काम बहुत आसान कर दिया. ओके, सो यू कैन इजीली स्टडी द वेरिएशंस इन द वेजिटेशन पैटर्न लाइक दिस. दिस इज द इम्पोर्टेंस ऑफ स्पेक्ट्रल रिफ्लेक्टेंस.
सर जहाँ पे भी वैली वाला ग्राफ बनता है तो इंटरप्रेट करते हैं कि वो वेजिटेशन पोर्शन रहेगा.
नहीं, वो पूरा ग्राफ ही वेजिटेशन का है. द एंटायर कर्व इज ऑफ वेजिटेशन. ओके, but at some point you are getting valleys or the region of least absorption. तो कुछ तो चेंज हुआ होगा कि abnormality आ रही है. Okay, we'll detect that abnormality and we'll identify. Okay, like this, because you know this place, particular place, at what place you are doing this. Okay, so there are different types of reflectance curves for quartz. Okay, for pyroxene, for kaolinite, for calcite, for hematite. Okay, so from the reflectance curves you can identify the rock type also. Okay, हमको सिर्फ मशीन में डाटा फीड करना है, देन मशीन अपना काम ऑटोमेटिक कर लेगा. वही खुद ऑटोमेटिक आपको आइडेंटिफाई करके लिथोलॉजी का मैप बना के दे देगी. Okay, you just need to feed the data in the computers. Okay, then you will automatically receive the prepared map, lithological map. Okay, like this. Okay, so this is reflectance of rocks. Now we have one very interesting phenomenon of oil spills. Okay, you know the majority of the oil transportation जो होता है वो कहाँ से होता है? Through seas. Okay, now we have started transportation through the rivers. Okay, what's that Haldia port, from the Haldia port. Okay, so before the BJP government, okay, nobody is thought of that we can travel through rivers, we can transport any ships through rivers also, because we have very big rivers like Ganga, then Hubli in Kolkata, okay, then Brahmaputra, okay, they are Narmada, they are very huge rivers. Okay, उनका ये जो है width है बहुत ही बड़ा है, very high width. Okay, very big channels. Okay, and high intensity of water, means plenty of amount of water. Okay, so we can easily, because transportation through, or the transport through ships or through via waterways is very cheap. Okay, so major oil transportations जो है वो कहाँ से होते हैं? Through seas. Okay, but what we are doing, let's say this is India. Now what India is doing nowadays, how diplomatic relations are managed. Here we have Myanmar. Okay, here we have Bangladesh, then here Myanmar. Okay, here we have Australia, let's say, और यहाँ पे है सिंगापुर वगैरह. Okay, and here you have China. So what China is doing, okay, all the transportation of China is from this way, वो यहाँ से आते हैं. I will use different color. Okay, okay, so Chinese ships are traveling from this side. Okay, again here they have land dispute with Japan here. Okay, here we have Japan, then उनको यहाँ से जाना पड़ता है. Okay, so they are investing, they are trying to invest in Myanmar as well as in these countries, okay, like Singapore, Thailand. Okay, and they are planning to make one personal tunnel here so that they can prioritize their transportation from here, oil transport. Okay, but if their ships and submarines are moving through this area, अगर यहाँ पैसा लगा दिया तो उनकी ये हो जाएगी, dominance हो जाएगा. They will get dominance over this area. Okay, and they will easily come near India. Okay, तो हमने क्या कर दिया, इंडियन गवर्नमेंट ने यहाँ पे इन्वेस्टमेंट शुरू कर दी. नाउ इंडियन गवर्नमेंट इज इन्वेस्टिंग इन म्यांमार, इन्वेस्टिंग here in Bangladesh, then Myanmar, in Singapore, Thailand. ओके, इनको इतना पैसा दे दिया कि इनको यहाँ से चाइना से पैसा लेकर, लोन लेकर ये टनल बनाने की जरूरत ही ना पड़े. ओके, तो उन्होंने अभी ये प्रोजेक्ट कैंसिल कर दिया, नहीं तो उन्होंने इसको मंजूरी दे दी थी. ओके, तो हमने ये वाला रास्ता जो है चाइना के लिए बंद कर दिया. नाउ उनके पास बचा दूसरा रास्ता. नाउ व्हाट दे आर डूइंग, ओके, दे हैव अनदर वे. ओके, दे आर मूविंग थ्रू दिस साइड. Okay, but now here Australia, again they have dispute with Australia. Okay, तो हमने ऑस्ट्रेलिया को अपना फ्रेंड बना दिया, क्वाड में शामिल कर लिया. Okay, and we signed the one MOU. Okay, so that we can exchange our air bases. Okay, तो हम सीधे अपने ships, aircrafts ऑस्ट्रेलिया में ला सकते हैं यहाँ पे, and same ऑस्ट्रेलिया भी इंडिया में ला सकते हैं. Okay, so now we are monitoring this way also. दिस दे आर इंटरनेशनल टेरिटरीज, ओके, सी ऑफ इंटरनेशनल टेरिटरी। हम उनको रोक तो नहीं सकते, बट डोमिनेंस नहीं दे सकते, मॉनिटर कर सकते। ओके, बट व्हाट दे आर डूइंग, उन्होंने क्या कर लिया, एक श्रीलंका में एक पोर्ट ही खरीद लिया पूरा पैसा लगा के। तो यहाँ पे हम थोड़ा फंस गए। हम्बन टोटा सुना होगा आपने शायद। ओके, so they are moving through this way, okay, and they are moving their ships from between Sri Lanka and India, okay, like this. Here in the here we have Gulf countries, okay, source of oil, but यहाँ पे सोमालिया के पास भी हमने एक पोर्ट ही खरीद लिया, ओके, श्रीलंका में भी हमने अपना एक पोर्ट खरीद लिया, okay. So we have one port in Sri Lanka, here in near Somalia island, near Madagascar, okay. तो उन्होंने पूरा चेन बनाया था, नेकलेस बनाया था इंडिया को ब्लॉक करने के लिए। तो हमने भी क्या किया, काउंटर नेकलेस बना दिया। यहाँ पे इन्वेस्टमेंट किया, यहाँ पे इन्वेस्टमेंट किया, गल्फ कंट्रीज में इन्वेस्टमेंट किया। इधर हमारे पास इस साइड में अफगानिस्तान है, पाकिस्तान को रोकने के लिए। हियर वी हैव इजराइल, ओके, टू मॉनिटर द गल्फ कंट्रीज, ओके। सो हमने क्या कर लिया, सारे यहाँ के जो फॉरेन रिलेशंस है इनको दोस्त बना दिया, इन्वेस्टमेंट किया, ट्रेड बढ़ा दिया, लाइक दिस, और उनको उनकी चाल में ब्लॉक कर दिया। नाउ व्हाट चाइना इज डूइंग, चाइना इज प्लानिंग सीपीसी थ्रू पाक ऑक्युपाइड कश्मीर। इसको भी हमने ब्लॉक करके रखा है। सियाचिन को हमने पकड़ में ला लिया और यहाँ पे कोई आ नहीं सकता। हमने वहाँ पे एयरपोर्ट बना दिया। हाईएस्ट पीक है हिमालय का, सियाचिन ग्लेशियर्स। So like this method we are blocking our enemies, okay. This is foreign diplomacy, and that is the reason we are investing in foreign countries so much, instead of थोड़ा सा कंट्री की हालत सुधारने से बेटर वो फॉरेन ट्रेड्स में विजिट्स कर रहे हैं, इन्वेस्टमेंट्स कर रहे हैं, ओके। ये हर किसी को नहीं समझता ये। Again, okay, so this is the I am talking about actually why, because main this is your oil routes, okay. This is for oil routes for China, okay, not only for China, for majority of the countries, because we have the source of petroleum here, Gulf countries, okay. So everyone is buying petrol from here, okay, and they are transporting to their countries, okay, via various ways, like this, okay. So this is actually the major route of petroleum, okay, जिस पर चाइना अपना अथॉरिटी लाना चाहता है। तो ये सबका है, बाकी लोगों का कहना है कि ये सबका है, तो कोई अपना वर्चस्व इस पे ना दिखाए बस। So this is the main territory. So just because of the movement of ships here, from movement of petroleum ships here, okay, many leakages happen, okay, petroleum leakages, कुछ ships में आग लग जाती है, okay. So you know that because of the low density of the oil, okay, oil floats on the water, okay. So this is your water, okay. So oil will cover the entire surface of water very easily, okay. So oil can block the mixing of oxygen in the below water. Also it can reduce the sunlight, okay, due to which the aquatic life is in danger due to oil spills, okay. Also the pollution different रहेगा, okay. So due to just because of this oil spill, okay, वहाँ की aquatic life danger में आ जाती है, and pollution होगा वो अलग, okay. So that is the reason, okay. So we can monitor this oil spills, okay, or the spreading of this oil spill with the help of satellite imageries, okay. Let's say this is the source of leakage, okay. This is the main oil spread, okay, Molusi. This is the main oil spread region, okay. और थोड़ा थोड़ा इतनी रेडियस में वो फैल चुका है, like this, okay. Because these oil spills are very rapidly spread, and they are covering very large areas. Okay, to monitor them or to mitigate them, where remote sensing is very useful. Okay, ultraviolet imaging is highly sensitive remote sensing method for detecting oil on water surface and is capable of detecting very thin oil films. Okay, so Landsat MSS is used for this purpose. This is very useful. क्लियर? इंडिया ने और एक चीज कर दी है. Okay, what Myanmar is doing. Okay, Myanmar is purchasing oil from the Gulf countries. Okay, then after purchasing the crude oil, okay, they are transporting all entire crude oil to China. Then China उनको refine करके, okay, to the China for refining. Okay, then China is refining the petroleum for Myanmar. Okay, और रेट बढ़ा के म्यांमार को ही बेच देते, because they don't have refinery, petroleum refinery. Okay, we have refineries in Assam, in Gujarat. Okay, so now what we are decided, or Indian government decided, they are constructing a refinery in Myanmar with our own money. Okay, तो हमने क्या कर दिया, आर्थिक चोट देना शुरू कर दिया, रास्ते ब्लॉक कर दिए, उनके बिजनेसेस बंद कर दिए, बिजनेसेस पे उन कंट्रीज को अल्टरनेटिव दे दिए सस्ते में, तो वो सब हमारे तरफ आना शुरू हो गए. Okay, so we started constructing one petroleum refinery in Myanmar. Myanmar easily ready हो गया क्योंकि उनका पेट्रोलियम लगभग आधा हो जाएगा, सस्ता हो जाएगा. आधा means if they are selling their petroleum for let's say 100 rupees, okay, now if they have refinery, they can easily sell petroleum for 60 rupees like this. Okay, हमारा क्या फायदा है? Okay, पहले हम इन्वेस्ट करेंगे, then in form of some form of royalty या some sort of commission, हम वो पैसा धीरे धीरे निकाल लेंगे आने वाले 10 साल में, 20 साल में, like this. Okay, and it is beneficial for म्यांमार. ओके, क्योंकि वहाँ के लोग ही उसे मैनेज करेंगे, संभालेंगे. ओके, अथॉरिटी हमारी रहेगी, वहाँ के लोग काम करेंगे. ओके, सो इट इज़ वेरी बेनिफिशियल फॉर देम एज वेल एज. ओके, मेन हमारा पर्पस, पैसे तो हमको थोड़े टाइम से निकालेंगे, हमने लोन दिया ऐसा समझ के, बट मेन इफ म्यांमार इज हैविंग देयर ओन रिफाइनरी, ओके, तो वो अपना पूरा का पूरा पेट्रोलियम जो है चाइना को भेजना बंद कर देगा, वो खुद ही रिफाइन करेगा और चलाएगा. Also we can use that refinery to refine the petroleum of any other nearby countries. Okay, like Bangladesh, उनके पास भी नहीं है तो हम उनको दे सकते हैं रिफाइन करके, like this. So this international territories, monitoring of movement of aircraft, monitoring of submarines. Okay, we can use the remote sensing or satellite data for all these purposes. Clear? So we'll stop here.